Level Control Setup Test Experiment Mode 1. Manual control is performed using the PID controller module on the right. The water flow rate is controlled by manually adjusting the opening and closing degree of the proportional valve. Now let's begin the experimental procedure. Open the accompanying software on your computer. Open Curve button. Data can be collected normally at this time. As you can see on the screen, the mode is set to manual. However, neither the Mode 1 nor Mode 2 indicator lights illuminated. The mode switch needs to be set to Mode 1. When Mode 1 is selected, there are two states, automatic and manual. This demonstration shows the manual mode in Mode 1. Click Run. Start the water pump. Turn the pump up to 100% maximum. The water pump started running. The flow rate is low at this time because the forced output is 0. Configure manual output. The maximum setting can be 100%, but we'll start by setting it to 50% and observe the experimental results. The flow meter level can be set to start rising. The rise reached the overflow state. The water flows back to the tank through the overflow port inside the container. It is important to note that the water tank must be filled with water before the experiment. The container is about to overflow. The PID controller displays the current liquid level as 224 mm. That is, the liquid level in the container is 224 mm. The software also shows the liquid level is 224 mm. The current flow rate is 7 liters per minute. The curve is also at 224 mm. It should be noted that the current proportional valve is at 50% opening. Now set the opening degree to 100%. After the settings are complete, you can clearly hear the sound of the proportional valve starting up. When the opening degree is 50%, overflow has already occurred. Therefore, the highest liquid level is 225 mm. To compare the effects, the opening degree was adjusted to 10%. The liquid level in the flow meter began to drop. The liquid level inside the container also began to drop. This is equivalent to controlling the liquid level in the container to begin decreasing by adjusting the opening degree of the proportional valve. It is important to note that for the safety of the equipment during operation. The outputs of the two PID controllers are 0. PID output is 10%. The proportional valve does not close completely. If it is completely closed, it will damage the water pump below. Therefore, the proportional valve has a slight opening margin to ensure a constant flow of water and prevent the water pump from becoming clogged. The liquid level at this time is approximately 9 millimeters. Additionally, it should be noted that at the start of the experiment, the hand valve for returning water needs to be turned to a 45 angle. Only then can all the experiments be carried out. This experiment is the manual experiment of Mode 1. Next, we'll demonstrate the automatic mode of Mode 1. First, turn the lower manual valve to 90. The upper manual valve points to 50. The experiment demonstration was still conducted in Mode 1. Set the status to automatic. PID values, set P to 9, I to 120, and D to 0. Next, we set the target value, currently set to 50. Change it to 100 and observe the change in the curve. Blue represents the set value, and red represents the actual value. The actual liquid level can be seen to be rising. The gauges also show that the actual liquid level has now risen to 100. The curves provide a more intuitive view of how PID Controller-1 controls the opening and closing degree of the proportional valve. This controls the liquid level flowing into the container to reach the target value. The curve shows that the actual value is very close to the target value. At this point, the PID output is 40%, and it is still changing. Wait for a period of time until the actual value and the target value lines completely coincide. At this point, the actual value can be seen from the instrument room to be the same as the set value. In the graph, the lines for the actual value and the set value completely overlap. It has reached the expected state. This is a demonstration of using PID control to achieve the set liquid level from the actual liquid level. We can also increase the disturbance by moving the manual valve, disrupting the current balance. When the hand valve angle is adjusted, the actual value changes. As can be seen from the graph, the curve changes immediately after the perturbation is added. However, the disturbance will then be eliminated through PID control. Achieving a state of equilibrium. This process also requires waiting for a period of time to change. After a period of time, the actual value is the same as the set value. The graph shows that when two values are the same, the lines overlap. This is an experimental demonstration of PID control after adding disturbance. You can also view the changes in the data in detail using the table. Experiment ended.